the CAT machine is nothing but your CT scan machine. We went through your CT scan machine. We understood how it works. We how the inner diagram of the machine is. We went through all those things. Okay. Then yeah. Next, going forward, this was the major thing in the previous class. That is, we went to the key steps in your digital image processing, starting from image acquisition. The first thing we saw was image acquisition, how the image is acquired, and all those things we saw. Next, going ahead, we saw your enhancement, there wherein we tried to increase the quality. Then came right on how we can restore an image, and there are types. One is objective and another one is subjective. All those things we saw. And going forward, we also saw morphological processing, how the processing is done, how you do your XOR and all those things. And that was seen. Then next we saw is your segmentation, how the segmentation is done, why segmentation is important, how can we process or a digital image with a proper segmentation method, and why segmentation forms a very important part of your image processing. Next, we saw your image recognition, that is object recognition. We saw a very beautiful example which you had also seen in your previous subject, the differentiation of flowers, that is Virginica, versicolor, and setosa. Then we came across your representation, that is representation and description. There are two types of representation. One is body representation and another one is internal representation. You can use any one of them. Finally, we came to your compression, which forms a very major part when you especially deal with your online things. So compression, any compression standard you know, guys? Any one of you? Any compression standard you know? A very famous compression standard. Bhavya, have you come? Are you online? No, Bhavya is still sleeping. Yeah, Zaid, right, zip is one of them. Anything else? Any other thing you know? Compression standard? Anybody?
JPEG, PNG.
Who is this?
It's Prashil.
Yeah, fine. Very good. So JPEG is one such famous standard which we all know, which is a compression standard for your images, and we'll be dealing in much detail regarding this compression as and when we move ahead. Just try to understand for now that compression also forms a very major role in your image processing. Why? Because it will be storing a lot of amount of data as well as the bandwidth. Remember, two things are very important. Sorry, bandwidth and your memory. Memory when you try to store it, bandwidth when you try to transmit it from one place to another place with the help of the internet. Fine. So next thing is you have color processing. Color processing. In the color processing, we saw various things. That is, you came across your image acquisition, enhancement, restoration, and some morphological processing. Finally, segmentation, recognition, representation, and description. So even this was covered in the previous class. Fine. So these all had been covered in the previous class. Today, we'll move one step ahead and we'll try to check upon what are your various components of an image processing system. So what could be your various components of an image processing system that we'll try to check upon today. We'll try to see what all are the requirements. If I go ahead and try to do image processing, what are the basic requirements to do that image processing we will be seeing today. So, yeah. So if you observe the slide, the first section we have is nothing but your image sensor. So this will be the first thing. The image sensor will be the first thing. From the image sensors, we need to move ahead to the next one, which is nothing but your image processing hardware. From the image processing hardware, we'll be moving to your computer. Then we will be moving to your mass storage, and then we'll be going to display it. We'll be displaying it, and in the meanwhile, you can also take down your hard copy. So you can observe the diagram here, your symbol here. In the meantime, we'll be also taking the hard copy. So remember, friends, the problem domain enters with your image sensors, then the hardware, then comes is your computer. Then usually sometimes if I don't want to store, then you directly jump to your image display. If you want to store, then you'll be going for your storage. In the meantime, we also need to check upon your image processing software. So even this forms a very major part. How the image is processed, how the image is processed, we need to understand it. If I want to understand how the image is processed, then it is very important that I should be knowing some algorithms. That is nothing but your software. Okay, so this is again important, friends. That is how you do your image processing. That is what all are required. So first we'll start with your image sensors. So when I speak of image sensors, your image sensors is basically made up of two things. One is your physical device, that is sensing device, and the other one is your digitizer. So whenever we speak of your physical device, it is nothing but it tries to sense the energy which is radiated by the object. That is, say for example, if I want to click an tree, I would say I want to click a tree, then your image sensor will try to check what energy that tree is being emitted. So it will sense that image. The physical device here is nothing but the sensor. It will sense that energy and then it will be sending it to the digitizer. I hope the digitizer at least is clear. Digitizer is nothing but it tries to digitize whatever the output you have received from the sensing device. Usually the sensing devices, most of our sensing devices give the output in the form of the analog. But what we actually require, we require the output in the form of the digital. So therefore, the digitizer is very much essential, which will convert the the output of your sensing device into a digital format. So that itself is your image sensor. To give you a simple example, you can take the example of your video camera, wherein the sensors will be generating an electrical output. The sensors will generate an electrical output in proportion with the intensity. Say for example, you are shooting a tree in the daylight, then the intensity will be very, very high. Right? Say for example, on the scale of 100, say it is somewhere around 90. And if you are shooting a tree in the night, then the intensity will be very low. Say on the scale of 100, it will be somewhere around 50. So based on this 90 and 50 values, your sensor values will be generating an electrical output. That is, say for 90, the electrical output will be high. For 50, the electrical output will be low. So this is what is your image sensors. This is very much essential if you want to sense an image and if you want to capture it. So first is your image sensor. I hope image sensor is clear. From the image sensor, we'll move ahead with your hardware image processing specializations. So here when you speak of hardware image processing specializations, it basically consists of again two things. One is again your digitizer and other one is your ALU. So if you want to process anything, what you require is your arithmetic and logical unit, wherein you will be trying to process whatever the images you have received. So say for example, you have received an image and you want to remove noise. You want to reduce the noise. Then your ALU comes into picture. First, what you do, you take the image, you digitize it. Say it has been already digitized in your sensor, but in this image processing hardware, again there is a digitizer which will further digitize it, and then it will be sending it to the ALU, wherein the ALU will do some calculations and it will try to reduce the noise. So why this unit is important? This unit plays a major role when you want to process your videos or images. Say for example, I have a video which is running at a high speed and I want to reduce the speed of that video. Then the work of your specialized image processing hardware comes into picture, wherein it has an ALU. This has an ALU. So using ALU, it will be trying to reshape your video. So it is very much essential. ALU forms the major role in this whole thing. Okay. So this is done, friends. Next comes is nothing but your computer. From your ALU or will be moving directly into computer. So computer is nothing but the normal computer. Basically, we try to use the normal computers, but there are some applications wherein we require very high-end and sophisticated computers, like say for example your supercomputers. So why the supercomputers is required is, say if I want to process the images of very high quality, then you will be requiring your high-end supercomputers. Okay, so most of the times we require a general purpose machine, so that is very much sufficient. Okay, so from here, from the computer, we try to move to your software. Why? Because we have got your image. The next very important thing we need to do is what actually I should do with that image. What actually I should do with that image, that is very much essential. So then we will move to your image processing software. Now, when you speak of software, you already know, guys, you all are software guys. This software is nothing but it usually comes in the form of a package, and it tries to do specific tasks. There are n number of softwares, n number of algorithms which help you to process an image. And what it actually, am I audible? There was a internet connection fault. Am I audible?
Yes, sir.
Yeah, thank you. Yeah. So yeah, going back to the class. So the image, sorry, we are speaking of software. Yeah, software's modules are there, n number of modules are there, which we try to integrate with the general purpose software commands, and then we try to get your required output. So this is software. We'll be coming across more about software in the upcoming classes, because you need to learn only processing an image is not sufficient. You need to only processing an image means only taking an image is not sufficient. You need to also process it. So if I want to process it, you require a software that is processing according to my applications, right? So I'll go into much deeper in the upcoming classes. For now, you just remember it comes in the form of a modules, or it comes in the form of a package, complete package, right? Next comes is your storage. So storage is very crucial, you can say, this storage. Why storage is crucial? Anybody? Anybody? Any idea why storage is crucial when you do image processing? Any one of you? Zaid says to store. Yeah, fine. That to store, it's crucial. Why we are written the word there, mass storage? To feed the initial data. Manjunath says to feed the initial data. Yeah. Any other answers? You can unmute and tell, no issues. Okay. To do so requires RAM. Fine. Now, I hope all of you have your cell phones with you. The smartphones, all of us have a cell phone, smartphone. So when you have a cell phone or a smartphone, what do you observe in it? What do you observe in it? You have n number of images, you have documents, yeah, you have videos, you have pictures, right? Can I ask you a simple question like, what takes more amount of storage, a document or an image? What takes more amount of storage, a document or an image? Jatin, can you answer? Jatin? Jatin, can you answer, Jatin? Yeah, okay, sorry, I was not seeing the chat. Yeah, it's an image, very good. So you can observe that an image takes more amount of data when you compare with your document. That's why the word here we have taken here is mass storage. It means that, why? Because if you observe, most of our images has somewhere around 1024 into 1024 pixels. So imagine 1024 cross 1024, which gives, and each pixel is somewhere around say 8 bits. The least we can observe is each pixel consists of 8 bits. Yeah, video is correct, but let us not discuss about video right now. We will stick up to your images itself. So each image has somewhere around 1024 into 1024 size, that is number of pixels. Say each pixel is made up of only 8 bits, will not take much, like 16 or 32 bits. Then if you consider only this much, then we require somewhere around 1 megabyte of storage space. And this is the case if the image is not compressed. And if the image is compressed, then we can reduce the amount of storage. But So whatever we are speaking right now is of a single image. Then imagine if you have more number of images, then there comes the problem of your storage. So therefore, the word mass storage, it means that we require huge amount of storage space when we are dealing with your images. Now, all your image processing applications will broadly categorize them into three categories. One is short-term storage, and in short-term storage, what we do is we store the image only when we'll be processing, right? Then we discard it or we don't store it in our hard drive. So this category is called as short-term storage, wherein we store it for only a small duration, only until we process it. The next category we have is online storage. So in online storage, this online storage is like your cache memory. I hope all of you might have heard of your cache memory. So what cache memory does? Cache memory provides us with the speed. Like say for example, I want to process an image or I want to fetch an image with a higher amount of speed. Then we use this online storage. Then the third comes is your archival storage. So archival storage, archival, the name itself is telling you, it has been archived. So say for example, you have collected an image in the childhood days and you want to keep it, you want to store it. Then what we do? We archive it. And we don't use it frequently. Such storage is called as archival storage. So I hope I'm clear. So storages in digital image processing are of three categories. One is short-term storage. In short-term storage, we store the image until we process it. Next comes is your online storage. The online storage is considered when you want speed, when you want to get an image at a faster speed. The third one is your archival storage. Archival storage comes into picture when we don't use that image frequently. So these are my three types of storage techniques. And usually, to give you a small glimpse of your short-term storage, what we do is inside short-term storage, we have something called as frame buffers. So we'll be using something called as frame buffers. Using frame buffers, you can store images at very rapid speed, and you can get them also at a very rapid speed. So this frame buffers are nothing but these are specialized image processing hardware units. So this whatever we are speaking right now, frame buffers, they don't come here in the mass storage. They will not be coming. So here in the mass storage they will not be coming. They will be coming here in the specialized image processing hardware. Why? Because these are some hardware units which help you to storage. Fine, they help you to do the storage, but where they come into the category of your specialized image processing hardware. Now, coming to your online storage. So I hope the frame buffers is an example for your short-term storage, right? Coming to your online storage, you can take the example of your magnetic disk or optical media. Any one of them can be taken as an example of your online storage. The third, archival storage. So as we spoke of archival storage, it is infrequently used. Again, you can take the example of your magnetic tapes or your optical discs. Any one of them can be taken as an example. So I hope the storage is clear. Storage forms a very major thing, and storage will be very crucial when you do your image processing. Now, one such very important thing which helps in storage is your compression. If you are able to compress the image, then you can go ahead and save a lot of storage in the system. Okay. Now, going from here, so we have finished your computer, we have finished your mass storage. Now let us move to your hard copy. So hard copy is very much essential. Now, when you speak of hard copy, it is, I hope I already know it. These are the devices which are used to record the image. Like any example would be your printers or cameras, or say any digital units such as CD, long disk. So all this will be coming in the picture of your hard copies. Okay. Now, next very important thing is your image display. So once you come to your image display, see, image display is another very major part. Why? Because if you remember in the history, that is during the 1920s and when we came to 1964, the major difference, one more major difference was, one, as you told, was tones. The number of tones were varying, right? The other major difference was the storage units or the receiver units. The receiver unit in your 1920 was a telegram machine. That is, whatever the person who was running there, you saw an image of a person running there. The image was stored with the help of the telegram machine. But in 1960s, we came across your television units. So we started using your television units. So therefore, the reception part was very much simplified in 1960s. So that means they had advanced in their image display techniques. So coming to image display techniques, friends. So preferably it will be monitors. It will be monitors or it would be display cards, which both form an integral part of your computer system. So you can say this image display is nothing but it is very much connected to your computer. Yeah, it is very much connected to your computer. Fine. So to give you a simple example, there are very rare requirements of image display applications. So that cannot be met with the help of the display cards. So most of them are commercially available. So in some cases, it is necessary to have the stereo displays, which is very rare. And these are implemented in the form of the headgear. So, and they have two small displays. One would be embedded in your goggles, who is wearing the user is wearing. The other would be at the other end. So don't worry about this thing. This one stereo displays. Right now, you just remember that image displays are nothing but your monitors. That is screens. Say for example, laptop monitors or TV screens or any one of them. Fine. So we have covered most of the things. We have covered most of the things in this diagram. So one small thing which is remaining in this diagram is anybody? One small thing which is remaining in your diagram is your network. Okay, so network, we know that it is nothing but it is one of the inseparable parts of computer system in these days. Without network, it becomes very much difficult to go ahead with your processing. Like most of our applications are depending on the network, which is nothing but your internet. Or it could be a LAN connection, or it could be an intranet. Right now, what we are dealing, right now, how we are communicating, it is again nothing but your internet. That is nothing but your network. So network is very much essential. Now, when we speak of network, we need to also consider your bandwidth. So here, one major constraint we have right now in today's world is bandwidth. Like when I say, am I audible? Why I'm asking that thing? Because I have a very lesser bandwidth. When some of your friends say, I have a network issue, it means nothing but the network is not able to reach that. That means the bandwidth is not sufficient. Or sometimes the best example of your bandwidth insufficiency would be, say, all of you are using YouTube and you are using one single Wi-Fi. I hope you are getting the scenario. One single Wi-Fi, all of you are viewing videos in YouTube. Then what would happen? The amount of bandwidth which is allocated to that particular Wi-Fi will be very less. Thereby, you will be observing that your video starts buffering. It will not be moving at a higher speed, or it will not be continuous. So therefore, network, when you speak of network, bandwidth is very important. The other major thing we need to see is efficiency. That is usually the efficiency and bandwidth both are interconnected. If you have a better bandwidth, then the efficiency would be automatically high. And when we have a dedicated network, say for example, my single system is connected through a LAN to a single router, then in that case we can say that my connection is very much clear. Okay, so friends, this is all regarding this thing, the whole general purpose network. So we have started with your image sensors. We have started with your image sensors, and we have reached it to 1 second. Yeah, we have started with your image sensors, and we have reached it to your specialized image processing hardware, and then we have went to your computer. From the computer, we tried to go to your software. From the software, we tried to jump to your storage. Then from the storage, we came to your hard copy. From the hard copy, we went to your display, and from the display, we have went to your network. So I hope this is clear, friends, right? Yeah. Maybe I will stop today's class here only because it's time up. So one second. So one humble request, friends, try to join the meeting as early as possible. We are getting late in it. Okay, so if you join the meeting quite soon, we can get more audience. And I can see people are exiting already. Don't exit the meeting. I have not yet shared the attendance link. So let us meet again tomorrow. I have shared my classroom link. So please try to enroll into the classroom so that if I share any assignments or any quizzes, I will be sharing in the classroom so you can easily attend it. Okay. Thank you.